know, in this video, we shall be looking at expressing numbers as product of prime factors. Now, two things are involved here: prime and factors. In our previous videos, we have treated what prime numbers are, and I took the time to list prime factors, prime numbers from 1 to 100. And also we have addressed factors of numbers in our previous videos. But for the sake of this video, I will just go over them briefly. Let's start with prime numbers. What are prime numbers? Prime numbers are simply numbers that have only two factors. In other words, only two numbers can divide into them without leaving any remainder. Prime numbers are numbers that can be divided by only one and themselves. Now look at these numbers: 2, 3, 5, 7, 11, 13, 17. Now, all these numbers here are prime numbers because only one and themselves can divide them. Look at 2. Only 1 and 2 can divide into 2. Only 1 and 3 can divide into 3 without leaving any remainder. The same thing goes for 5, 7, 11, 13, and 17. Only 1 and 13 can divide 13. Only 1 and 17 can divide 17. These kind of numbers are known as prime numbers. I will suggest that you look at the videos where we took time to talk about prime numbers, and I even listed prime numbers from between 1 and 100 in that video. So take time and watch that video. So that is it for now. Prime numbers are simply numbers that have two factors. Only two numbers can divide them, and those two numbers are 1 and themselves. Now, having said that, let's go into expressing numbers as product of prime factors. Now, there are two methods to this. One is what is known as factor trees. Factor tree, a tree. It's called a factor tree because it looks like a tree, a tree with branches. And then another method is prime factorization. So there are two methods to solving this problem. So let's start with the first method. That is, let's start with prime factorization. So let's say you are asked to express, let's look at this. Express (36) as a product of its prime factors. Now, to solve this using prime factorization, you write 36, something like this. Draw a line like this. You now ask yourself, what number can divide 36 without leaving any remainder? And the number you put here must be a prime number. That number must be a prime number. So let's start. 2 can go, 3 can go, Yes. So let's start with 2. 2 into 36. Yeah, 1 here, and 1 into 16. 8. 2 can go to 9. 9 times. 3 can go. 3 into 9 will give us 3. 3 can go. 3 into 3 will give us 1. Now, once you reach here, all you need to do is simply write 36. 36 is now equal to 2 times 2 times 3 times 3. This is what it means to express a number as products. You know, product means what you get when you multiply numbers. Like 2 times 2 is 6. So the product of 2 and 3 is 6. So to express a number as product of its prime factors is just to express it in this manner. Now, you notice that all these numbers here, they are factors of 36. Apart from that, they are also prime numbers. That's how we get the prime factor. So here, this number has been expressed as product of its prime numbers. The numbers here are all factors of 36, and they are prime numbers. So that is basically what it means. This method is what we call prime factorization. Prime factorization. Now, this is another example. Here you have to express 56 as a product of its prime factors. Simple. Write 56 like this. Draw a line. What are the factors of 56? Numbers that can divide 56 without remainder, that are also prime numbers. 2. Can 2 divide this without remainder? Yes. So 2 into 5 is 2, remainder 1. Into 16 is 8. 2 can divide again. 2 will give us 1, 4. 2 can divide again. 2 will give us 7. And then we use 7 there, 1. Now, notice that 2 is a factor of 56, and 7 also is a factor of 56, and they are all prime numbers. So, to express 56 as one of its prime factor, just write 56 here. Give the answer. 2 times 2 times this 2 and times this 7. That is simply expressing 56 as product of its prime factors. So I want to believe that this is clear enough. Now, in the next video, we shall be solving this same problem using the other method, which is the factor 3 method. Factor 3 method. This method is called prime factorization. Prime. It's called prime factorization method because all the numbers here must be prime numbers, and they're also factors of the number. So that's how we get the name prime factorization, using prime numbers that are factors of this number. So that's it. In our next video, we will look at doing this using factor 3 method. Thank you very much for watching.